Welcome everyone to this session about understanding p-values and confidence intervals. So in this session, we will be talking about the concept of p-values and confidence interval using practical examples relevant to traumatic brain injury and colorectal cancer. So in principle, p-values and confidence intervals are statistical tools that help us understand the significance and the reliability of research findings. To be specific, for this session, we will be discussing what hypothesis testing is, what a p-value means, and what confidence interval or CI is. And finally, we will conclude how to interpret them in clinical and epidemiological research studies with examples relevant to traumatic brain injury and colorectal cancer. So this is a brief outline and objective for this short session. Before we start, we need to illustrate the differences or different types of hypotheses that we start the research project with. We have two types of hypotheses. The first one is called the null hypothesis, when we assume that there's no effect or no difference between the groups or no effect of the intervention that we are going to do. As an example, in a study testing a new TPI treatment, the null hypothesis would be the new treatment has no effect on patient recovery compared to standard care. On the other hand, we have another hypothesis is called alternative hypothesis. So this is the hypothesis that we want to test or do all the testing. It suggests that there is a significant effect or difference when we talk about different types of groups or significant effect of treatment. As an example, the alternative hypothesis in this case would be the new TPI treatment improves patient recovery compared to standard care. So in principle, every research project or epidemiological research projects normally starts with different types of hypotheses which we want to test in order to conclude an outcome. So the null hypothesis, it assumes that there's no effect and no difference for the new proposed treatment or the new proposed intervention. But on the other hand, we have another alternative hypothesis, which says that the new treatment or the new intervention is effective. So the research aims to test these hypotheses, then make a conclusion about whether to accept or reject the new treatment as effective or not effective. Later on, we will explain this with further examples to illustrate the differences and how do we do that testing specifically. So we have two expectations when we deal with hypothesis testing. For the null hypothesis, this can be rejected or can be failed to be rejected. As you see in the first example, rejecting the null hypothesis, when we obtain a p-value lower than 0.05, we reject the null hypothesis, meaning that there is enough evidence to support the alternative hypothesis. In different words, the null hypothesis says that the treatment is not effective, or there's no relationship, or there's no difference among groups. So when we have as an outcome after doing the data analysis a low p-value, which is normally lower 0.05 as in the first example, so we say that the null hypothesis that assumes no effect or no relationship can be rejected, and this means we have enough evidence to support the alternative hypothesis, which on the other hand states yes, the drug is effective or the intervention is effective. For example, in a colorectal drug trial, the p-value was 0.05. In this case, we reject the null hypothesis and conclude that the drug likely has a significant effect. Why did we reject the null hypothesis? Because the generated or the outcome p-value was small. And next we will explain what do we mean by p-value. But for now, I want you to understand how it works when we reject the null hypothesis or fail to reject the null hypothesis. The other scenario is called fail to reject the null hypothesis. This happens when we have a p-value that is greater than 0.05. So we fail to reject that null hypothesis, meaning that there is not enough evidence to prove the alternative hypothesis. In this case, for example, in a TPI study, we have had a p-value of 0.05, which is greater than 0.05. In this case, the 0.08 is considered to be a big or large p-value. So we cannot reject the null hypothesis that assumes no effect or no difference. So we cannot also confidently say that the treatment is effective. So the idea is here around rejecting the null hypothesis. So when we reject the null hypothesis, we conclude that the treatment is effective or the difference is significant. On the other hand, when we cannot or fail to reject the null hypothesis due to a big or large p-value, we cannot have enough evidence to support the alternative hypothesis, which is the main thing it revolves around, which is stating the treatment is effective. So this is a basically introduction about hypothesis testing and how do we use the p-value in order to test those hypotheses. Now let's talk about the p-value per se. So a p-value tells us the probability of observing results we have if the null hypothesis is true. Remember, the null hypothesis was about stating no effect or no relationship. It's a no hypothesis. That's why we call it a null hypothesis. So whenever we have this probability as a low number or very small number, it's easy to reject that null hypothesis. But when we have that p-value as a big number, which is normally more than 0.05, we cannot or we fail to reject that null hypothesis that says no effect or no relationship. So the null hypothesis is an assumption that we made initially before doing the research that there is no effect or no difference. I want you to remember that these null hypotheses is mainly about no effect or no difference. So when we have a low p-value, typically less than 0.05 reported in research studies or epidemiological studies, this means that the result is unlikely to be due to chance. So we reject the null hypothesis that says no effect or no difference. So when we do that reject, on the other hand, it's more likely we could accept the alternative hypothesis, which says the treatment might be affected in this case. So this is basically the p-value. So the smaller the p-value, we reject that null hypothesis if that was below 0.05. If that p-value was more than 0.05, we fail to reject that null hypothesis, so we cannot support the alternative hypothesis that states the treatment is effective. Right. So let's have this example, practical example, using a colorectal cancer study. So let's say we conducted a study on a new chemotherapy or treatment drug for colorectal cancer. And the p-value generated after collecting and analyzing the clinical data was 0.03, which is a very small p-value. So this means that there is a 3% chance that the difference in survival rates between the drug group and the placebo group is due to chance, which is a very, very, very small chance, in this case, 3%. So this will help us to reject that null hypothesis, the hypothesis that states the treatment is not effective. So since the 0.03 is less than 0.05, which is the threshold or the point that we rely our decision on, so we would consider this result as statistically significant, meaning we reject the null hypothesis that says the treatment is not effective and conclude that the drug may be effective. So we need to look at the p-value. The smaller the p-value, typically less than 0.05, in order to say, yes, the null hypothesis that says no treatment is effective or the treatment is not effective can be easily rejected in this case. The other statistical significance component or element is called confidence interval. So what do we mean by these confidence intervals? So a confidence interval is a range. So a range that starts by a lower value to a higher value that we believe contains the true effect of or the results of the total population. So this range will most likely include the true effect of that medication or that intervention or the true results of the general population. In more detail, a 95% confidence interval means that if we repeated the study 100 times or the intervention 100 times, the result or the true results would fall within this range 95 times. So normally this range will include the possible outcomes or the possible results. Let's see another practical example and how do we use confidence intervals in order to test the hypothesis. So in a clinical trial about colorectal cancer, the relative risk, which is one of the epidemiological measures that we covered of death, okay, which is the probability or the likelihood of death for patient on a new drug might be 0.08 with a confidence interval 95% confidence interval ranging from 0.7 to 0.9. Remember, confidence interval is not a fixed number, it's a range. And this range will be suggested and provided by the statistical software when we analyze the data. So it's not a constant or fixed number that we get for all studies. So what does it mean to have this relative risk of 0.8 according to this confidence interval from 0.7 to 0.9? Our interpretation would be the true relative risk reduction in the death or mortality of those patients is likely to be between 10% and 30%. How did we get this 10% and the other 30%? Because if we have the probability of death from 0.7 to 0.9, the opposite to death is a survival, which is 10%, the completion to 100 to 30%. So since this confidence interval does not include the null value, which is in the case of hazard ratio or relative risk, is the value of 1. So this result is statistically significant, meaning that the new drug is likely to reduce the risk of death. So talking about these null values in the previous session, we covered the different types of measures and different types of possible values and including the null value. So whenever this confidence interval includes the null value, we cannot say that that result is statistically significant because the null value means the treatment is not effective or the probability is not increasing or not decreasing. Further interpretation for the confidence interval. So when we have a narrow confidence interval, that means the estimate is precise. So while wider confidence intervals means that there is more uncertainty about the true effect. Remember, this interval, including the lower limit and the upper limit, includes the actual range or the true value of that intervention. So if a confidence interval includes the null value, for example, in the case of relative risk and odds ratio, the value of 1 or a value of 0 for the case of mean difference or mean effect, the result is not statistically significant. And later on, when we have more examples, we will have different scenarios. So we could say the result is statistically significant or not statistically significant using the confidence interval. So as an example, using a TBI study, let's say a study examines the effect of a new therapy on TBI recovery, reporting a mean improvement score difference of 3 points with a confidence interval ranging from -1 to 7 points. So in this case, we look at the interval. Does this interval include the null value? Yes, it includes the value of 0 when the range starts from -1 to 7. So in this case, we talk about mean difference, and the null value for this mean difference is 0. So we cannot confidently say that the therapy, the true effect, could positive and negative or no effect at all. So we cannot examine the therapy or we cannot confirm the effectiveness of that therapy because the confidence interval includes the null value, which is 0 in this case. So both p-values and confidence intervals provide us with useful and beneficial information, but mostly the confidence interval provide more context and more precise interpretation by showing the range of possible effect or the size of that effect. For example, in a TPI study, the p-value was 0.04, indicates significance because it's less than 0.05, but the confidence interval of a range from 0.5 to 0.95 of a hazard ratio, which is the risk of death in this case, gives us more information about the potential size and the direction of that effect. So we need to rely on both confidence interval and the p-value. This is another example. So a study results, a new chemotherapy drug for colorectal cancer shows a p-value of 0.02, which is a very small p-value, and a hazard ratio, which is the risk of death, in this case of 0.75, and that associated confidence interval was from 0.6 to 0.9. So how do we interpret this results or these results? The p-value interpretation will include statistical significance because the p-value was less than 0.05, suggesting the drug is effective. And the confidence interval, the drug reduces the hazard of death by 25% because the hazard of death was 75%. On the other hand, the survival probability will be 25%. So we are 95% confident that the true reduction is between the range of 10% and 40%, which are the completion of the values, the lower limit and the upper limit of the confidence interval. This is one example trial by Cooper et al. 2018. And this trial, they studied the effect of early sustained prophylactic hypothermia on neurologic outcomes among patients with severe traumatic brain injury. So patients were randomized into two different groups. The first group included patients exposed to the hypothermia. We call them the hypothermia group, and the other group included patients with no hypothermia, just a standard care. So what was the outcome for this study? If we look at this study and the associated interpretation, first we need to look at the p-values and confidence interval associated with this study. So what are the possible values for the absolute risk difference or absolute difference? We have three possible values. This could be below 0, or 0 in this case, which is the null hypothesis, or more than 0. For the relative risk, the possible values could be below 1, or 1, which is the null hypothesis, or null value in this case, or could be more than 1. How do we interpret these results? First, by looking at the p-value, none of the p-values is below 0.05, which means we have big p-values, meaning the observed effect is not significant or is insignificant. Okay, when we look at the confidence intervals at the same thing, we will see that all confidence intervals include the null value, meaning the observed effect is insignificant. So how do we interpret these things? We fail to reject the null hypothesis that assumes no effect of hypothermia. So when we look at the conclusion of this study, the study concludes that among patients with severe traumatic brain injury, early prophylactic hypothermia compared to normothermia did not improve neurologic outcomes. And how did we come up with this conclusion? Because according to the statistical significance, okay, we have had large p-values, and all of our confidence intervals included the null value. So it was impossible for us to reject the null hypothesis. So we would stick with that null hypothesis that states no difference between the hypothermia and the normothermia groups in terms of neurologic outcomes. Another example, this study published in the New England Journal of Medicine was about the effectiveness of colonoscopy screening on the risk of colorectal cancer and death. Okay, so we have patients who were invited, or people who were invited to a voluntary screening, and they wanted to associate the cancer diagnosis and the related death of that cancer with willingness to take that screening. So if we look at the findings and make further interpretation of these findings, for example, in this primary and secondary outcome table, we will see that the table reported risk difference and relative risk. Of course, we need to consider the possible values for this risk difference, which could be below 0 or 0, which is the null value in this case, or more than 0, or the relative risk, which includes 3 different possibilities: below 1, 1, which is the null value in this case, or more than 1. And how do we interpret these findings? We need to look at the confidence interval associated with these groups. So we have the first group called the invited group, who were invited to do the colonoscopy and their outcomes, and the other group, the usual care group, people who were not invited to do the colonoscopy. So if we look at the most confidence interval, they do not include the null value, except one case. which is the death from any cause. If we look at the colorectal cancer endpoint or the death endpoint from cancer itself, they do not include the null value, either the 0 or the 1, for both the risk difference and the relative risk. So we could say the observed difference or the observed effect is significant. In this case, we reject the null hypothesis that says no effect or no difference between subject who take the colonoscopy and subject who do not take the colonoscopy. So we assume that the screening and the colonoscopy screening is effective on the diagnosis of colorectal cancer and later on for possible death from colorectal cancer. So we need to look at these intervals and see if these intervals include the null value, yes or no. Then we say, yes, this is significant or not significant. And this is the conclusion of that trial. So in this randomized trial, the risk of colorectal cancer at 10 years was lower among participants who were invited to undergo screening colonoscopy than among who were assigned to no screening, which means screening colonoscopy is beneficial in detecting colorectal cancer at early stages and further preventing death or the escalation of that condition. So to conclude this session, p-values help us understand or determine if the results are statistically significant, so we can use them, but they do not provide us with information about the size, including the magnitude or the direction. On the other hand, confidence intervals give us a range of values that include the possible true effect with a precise insight into those results. So in conclusion, in clinical research, we always need to look at both p-values and confidence interval to get the full understanding of the results. So this concludes the session, and these are the references for you to read in full. Thank you for your time and good luck.